Hi there again. This is Efe Martins or Alagwa Benjamin if you find that simpler. In the first video, I introduced you to the whole idea behind exponents, power, or anything. And what we're going to do in this video is we're going to take a look at some basic principles which mathematicians like to call laws. But since we're not trying to be serious, let's just call them how to handle indices. Okay, it means whenever you see any question relating to power, index, indices, or anything, you know which of the laws you apply to them. Okay, so let's just get into it as we start. Now, the very first law you need to understand with indices is that any number, okay, any number raised to power zero, okay, let's have our number here, raised to power zero, is always one. Okay, so in case you're feeling smart with yourself and you want to ask, does that mean 700 raised to power 0 equal to 1? Yes, 7 raised to power 100, oh, excuse me, 700 raised to power 0 is equal to 1. So you ask again, what if it is 1 million? If you are feeling stubborn, 1 million raised to power 0 is it also equal to what? Is also equal to 1. So our first law of indices, okay, if you don't want to call them laws, this is my line. Looks like your leg. I'll try again. Okay. There we go. That's the straightest line you ever get on KBD. Anyway, 1 million raised to power 0 is equal to 1. But then, mathematicians don't just write these laws in numbers because what if you're faced with another number other than 700, another number other than 1 million? How do you approach that? So they use a big word called variables. Okay. I'm using variables because if I mention the word X or anything, you may start having a migraine. Headache will just start one time, say, hey, once I don't begin see letter inside maths like this, the thing they always fear me. But not to worry, let's just write it how it should be written. Let's pretend to be proper mathematicians. Rule 1, or let's say A, means A raised to power 0 equal to 1. So all these examples that I just showed you here are numbers that could have easily been the values of A themselves. So our first rule says A raised to power 0 is 1. So if you're faced with any exercise, like say evaluate 10 raised to power 0 plus 5, the answer is easily 6. Why? Because any number raised to power 0, forget all the firibon that the 10 is doing, even if it is 100 or 110, any number raised to power 0 is 1. So in essence, they're asking you to do 1 plus 5, which is equal to 6. Also, moving on, if it was, say, 1000 plus 3, what is the answer? Sorry, 1000 raised to power 0. All these plenty zero. It's a scam. Don't worry yourself. Everything is 1. 1 plus 3 equal to 4. So this is a pretty nifty law that will always help you whenever you need to evaluate things. So don't eat suya with it. Don't eat kose with it. Don't eat doya or anything that will make you forget. Any number raised to power 0 is equal to 1. You will need that rule one day. Now, the second rule I want us to talk about is multiplication of indices. I'll pick another color in case you have something against red or you're already looking confused. So let's call this one B. This one says A raised to power M multiplied by A raised to power N is equal to A raised to power M plus N. Take a look at this and try and make sense of what's really happening. Okay, it means if you have an evaluation where you're to multiply a certain number, A in this case, raised to a certain index. Mind you, index is the singular of indices. Indices is the plural of index. So M is an index, N is an index. Okay. So if you have to multiply these two numbers, what you should do is you just take their common base and add the indices or indexes. Please don't say that outside. I didn't teach you. Okay. You add the indices. So it means if someone gives you like something, say let's erase this. let them not think we are sloppy people. Let's erase this. I don't want to clean the whole screen. Okay, let's erase everything. Why is this so okay? Hmm. Bad, bad pass don't name on top. Oh, bad gone. Bad pass. Okay, I think this is usable, so we don't spend the whole day darkening the blackboard as you would. You see, blackboard, local people. Anyway, as I was saying, back to the back to the matter. If someone gives you a question that looks like say 5 raised to power 4 times 5 raised to power 7. Now, the thing is, 5 raised to power 4 is a fairly large number. Okay, it means 5 times 5 times 5 times 5. Now, the whole of this entity, you're trying to multiply it by 5 times 5 times 5 times 5. How many is that? 1, 2, 3, 4, 5, 6, 7. Okay, this is what you're trying to do. But some mathematicians who are obviously more hardworking than us, I mean, look at us online when these people were working it out on the board. So they already devised the method that once the bases are the same, this is the base, okay? The base is the bigger number here. The base is what you are raising to a certain power. The power here is the index, okay? Two of them are the indices. So to evaluate this expression, you just say 5 raised to power 4 times 5 raised to power 7 is equal to 5 raised to power 4 plus 7. I really hope you're not confused now. So it means our answer is 5 raised to power 4 plus 7, 11. How do we know if we're correct? Let's remove this bracket, okay? And just multiply everything. 5 times 5 times 5 times 5. Let's count the number of 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if you remember from the previous video, indices, indices is all about, how do I put it? Exponentials are all about repeated multiplication. So we have multiplied 5 by itself 11 times, which I've circled here. And without doing the stress in this case, that is what we actually got here. But in case you're feeling like a Thomas, I have one very nice calculator here, just to prove you wrong. Okay. Now, I hope the calculator does not intimidate you. Let me put it somewhere here. The same expression we are trying to do, 5 raised to power 4 times 5 raised to power 7. Okay. 5 raised to power, okay, this is called the caret symbol. 5 raised to power 4 times 5 raised to power 7. Okay, what do we have? Look, 488282125. Can you beat that? So how do we, what exactly am I trying to prove? Well, this is what I'm trying to prove. Now that we've done this, let's just evaluate 5 raised to power 11 directly and see what happened. How do you clear this? Okay, wow. Technological wizard. Technology wizard and the wizard. Forget it, I can use the calculator. So let's have 5 raised to power 11 directly. What do we have? Remember this figure? The same 488282125. So which means the whole idea about multiplying indices is once the bases are the same, anyway, the bases have to be the same for the laws of indices to hold, okay? So now that we agree that the bases are the same, which is 5 and 5 in this case, what do we do when it's multiplication? We just add the indices. Thank you, Mr. Calculator. So let's just have one more example and see how that works. If someone gives you 10 raised to power 4, okay, this color is getting boring. I don't like it anymore. 10 raised to power 4 multiplied by 10 raised to power 6. The answer is simple. Instead of writing it out like a bushman, just do 10 raised to power. Why are we having 10 raised to power? It's because the bases are the same, okay? The bases have to be the same for the laws of indices to apply. So your answer will also be the same base raised to what power? You now add the powers. What are the powers? We have power 4 plus power 6, okay? In case you're sleeping, this is where power 4 came from, and power 6 came from here. Okay, so you have 10 raised to power 10. Okay, in the next video, I'm going to show you other laws which you may not like, but then the whole idea is to spend as much time as we can and we grab this whole concept because these ideas are very important. These are the ideas built into calculators for processing and all sort of things you may want to do. These are ideas that you will still use in your in later mathematics classes for other sort of evaluations you may want to do. I think this English is getting too much and you're even confused about the English more than the maths, but not to waste time, I'll see you in the next video. Then we'll continue with the laws. Thank you very much.